Welcome. Today we're gonna solve an important DSA question, which is merge k sorted linked list. Previously, if you have watched my previous video, you might have seen we have done another problem in which we have merged two sorted linked lists. Merging two sorted linked lists is very easy, and merging k sorted linked list is a bit difficult if you see Leetcode. But if you've seen my video till the end, you will find this very easy. Okay, so we gonna do this with a easy approach. Okay, once I type the code, once I explain the code, you will find it very easier. Just watch this explanation till the end, and also I'll type the code here in Java, so don't worry, we're gonna do it in very easy way. Okay, so let's solve this. Okay, so for this I have taken this example. So I hope you have understood the question. We have this linked list here. Okay, this is sorted. Okay, 145, and we have this linked list, this is also sorted, and this linked list is also sorted. So what we're gonna do is we're gonna return a single linked list, which is the combination of this linked list, and this single list is also sorted. Okay, so we have, and here we don't know how many linked lists are they. Okay, they are k linked list. Okay, so what we're gonna do is we have I have taken this example. So with this example you can easily understand. Okay, so for example, I have three linked lists. Okay, let's assume we have three linked lists. Okay, so in the first linked list we have elements 1, 10, 20, then 4, 11, 13 in second linked list, and third linked list we have 3, 8, 9. For this we have to solve this question we use min priority queue. Okay, so as you know, in the min priority queue, what is going to happen is the smallest element would be at the front. Okay, the smallest element would be at the front. So we have elements in ascending order basically. Okay, so what we're gonna do is we'll create a dummy element. Okay, we create a dummy node. Okay, we'll create a dummy node, and what we'll do is we'll bring current node over this dummy node. I'll tell you why we use this current node. If you have watched my previous videos, you will know why we are doing this right now, but later you'll know when once I start solving this. Okay, so what we are doing, we are creating a dummy node, and we are bringing our current over this dummy node. Okay, for now this is what we understood. Okay, and then what I'll do is uh, I'll take I'll take all the heads. Okay, all the heads into my min priority queue. Okay, all the heads into my min priority queue. How I'll do this, we'll see. Okay, uh, let's. Okay, so what I'm gonna do is I'm gonna take all the heads into this min priority queue. So it would be 1, and then 3, and then 4. Okay, so 1, then 4. Why 1, then 3, then 4. Okay, why we are writing like this? Because in the min priority queue we have elements in ascending order. Okay, so what I'm going to do is, what I'm going to do is I'll check, okay, which is the smallest element among this min priority queue. I'll poll means I will remove that element. Okay, I'll remove that element, I'll keep that element in a new node. Okay, I'll create a new node. Okay, I'll create a new node. Okay, this is a min node. Okay, I'll name it as min node. Okay, new node. Okay, I'll create a new node, I'll keep that, and I'll poll that element. I'll poll the element from this min priority queue. Which element I'll get 1, because in the min priority queue we have one smallest element at the front. Okay, so I'll get 1 here. Okay, what now I'll do is I'll point my current next to this min. Okay, so this will create a link. Okay, and I'll move my current to this min node. Okay, how? Using current is equal to current dot next. So my current is now here. Okay, now what I'll do is I'll check is if my min node, okay, if my min node next is equal to null or not. What my min node is currently pointing at, it is pointing at 1, which is the start node, which is the head node of this linked list. Okay, does it is my so what we have, yes, we have 1 here. Okay, is once next null? No, once next is 10. So what we gonna do is we can gonna add that 10 to this min priority queue. Okay, let's do it. We're gonna add that. We have poll this, so it gonna remove, and then we have added a 10 here. Okay, so we have added a 10 here, and one is already in the linked list, so we're gonna remove it from here. Okay, so what we're gonna do now is, now we're gonna do this again. Okay, we'll create a min node. Okay, in the min node we're gonna poll one element from the min priority queue, which would be 3. Okay, after polling 3, what we're gonna do is we're gonna make current next is equal to min node. What this will do is this will again create a link with this min node. Okay, and we'll move our current to here. How we'll move? Current is equal to current dot next. Again, what we'll do, again we'll check. First we'll check. Okay, what we'll check, we'll check if min next is not equal to null. What is min pointing? What do we have in min? 3. Okay, 3. Is 3 next not equal to null? Yes, it is not equal to null. Then we'll again add that into priority queue. Okay, we'll add the min next to priority queue. What is min next here? It is 8, right? We'll add 8 to the priority queue. We'll add to 8 to the priority queue. After adding 8 to the priority, we have polled 3, and now we have added 8 to our priority queue. Okay, now again we'll do the same operation. What we're gonna do, we're gonna create a min node. We're gonna create a min node, and min next current next is equal to again we're gonna create a min node, and we're gonna pull the element from the min priority queue, which would be 4. Okay, and after pulling the element from the min priority queue, we will join that with the current. Okay, how we will join, how we will link? Using current next is equal to min node. So we'll form a link here, and then we will move our current to the next position, which would be like this. Okay, current is equal to current dot next. Again we're gonna check. Okay, again we're gonna check. Okay, what we'll check, we have whether our min node next is not equal to null. Min node next means what? 4 next not equal to null. Is 4 next not equal to null? Yes, it is not equal to null. If it is not equal to null, if it is not equal to null, what we'll do, add that element to the priority queue. We'll add that element to the priority queue. Okay, so we will add that to priority queue. By adding that element, we'll get this kind of priority queue, and since we have pulled out this, we'll delete this. Okay, now again what we're gonna do, we'll see what we'll create a min node. Okay, we'll create a min node again. Okay, we'll create a min node again, and what we'll do, we pop out 8, and then we're gonna form a link. How? Min using current next is equal to min node, and then we're gonna move current here. So if you are looking, if you are observing this pattern, you might have now understood that we are forming a single linked list, which in which every element is sorted. Okay, will do this operation until each of the linked list is not equal to null. Okay, we're gonna add those elements into this priority queue, and one by one we'll pull that and add to this linked list. Okay, so what will be our answer? Our answer would be dum dot next, because dum dot next is our linked list. Okay, so this would be our answer. We'll return dummy dot next. Okay, so let's do it in the form of code. You'll understand it better. Okay, so we know that we need a priority queue, so we're gonna write priority queue. Okay, priority queue is type of what? It is type of list node. Okay, so we're gonna write list node. Okay, we'll name it as pq new priority queue. Yes, and now we will tell this priority queue, we will teach that this priority queue which element is smaller and which what it should do. We'll tell whether it should be a min priority queue or max priority queue. How we will tell? See, like this. We'll take h1 and h2. Okay, we'll take h1 and h2, and what we'll do is we'll give h1 dot, what we have here, value, right? H1 dot value value minus h2 dot value. What this will do is this will make this priority queue as min priority queue. If you have if you would have done h2 value minus h1 value, it would have been a max priority queue. Okay, so first task is we have created a min priority queue like this. A task is to create a min priority queue. Now our task is to add the starting nodes of this linked list to this min priority queue. How we will do this? Using the for each loop. Okay, we know that the data type is here list node, and we'll take head from the list, and we will add that to priority. How we will add? pq dot add of this head. This will add all the heads to the min priority queue. Before adding all the heads to the priority queue, we will check if head not equal to null. Only then we will add. After doing this, what we will do? We will create this dummy node, and when we will bring our current to this dummy node. How we will create this dummy node? Using list node dum is equal to list node. Okay, we have created a dummy node, and what we'll do now, we'll bring our current to this dummy node. Okay, we have did this, and we have added all the heads to this priority queue, and we have made this dummy element, dummy node, and we have brought our current to this dummy node. Now what we will do is we will iterate. Okay, we will do this operation current is equal to current dot next, and we'll pop element from this priority queue, and we will add that to this current, and we'll move like that. Okay, we'll create this linked list. How we will do this until our priority queue gets empty. Okay, we will do this until our priority queue gets empty. If our priority queue is empty, what does that mean? That means that we don't have any element in either of the lists. Okay, then only our min priority queue is empty, and once our min priority is empty, we can return dummy dot next. Okay, so what we are doing is, see, what we are doing is we are first popping out the element. Okay, first element. How we will pop out? See, we will pop out like this. List node, we will create a min node. Okay, as I said, min node is equal to, we'll create a min node is equal to pq dot poll. This will poll out the element, and what we will do, current dot next is equal to min node. Okay, and also we will move our current to the current dot next. Okay, and off. What we have did here, we have created a min node and brought up and pulled out the first element of the uh, min priority queue, and stored it in the this min node. Okay, after storing it, what we are doing, we are creating a connection. We are joining it. How? Current dot next is equal to min node, current dot next is equal to min node. Okay, and after that we are moving our current also here. Okay, we are writing that only here. Okay, once you understand this diagram and all, you can easily write the code according to that. Okay, after making this, next what we are doing, we are checking if our min node dot next not equal to null. If our min dot next, see, currently our min is 8. Okay, 8 dot next is equal to null. 8 dot next is not equal to null, it is 9. So what we'll do, we'll add 9 to this priority queue. Okay, if it is not null, what we'll do, we'll add that to priority queue. We'll add what? We'll add min dot next element. Okay, after, so our code is almost over. What we have to do is, now we have to return. Okay, now we have to return. What we will return dummy dot next. Okay, and before doing this, we will check if we will check one condition. if list if list dot size, if list is if list is empty. Okay, If list is empty, we will return null. Okay, let's see if this works. We might get an error. Okay, what it is saying, return dumb dot next. Oh, okay, let's see what is the problem. Return dumb dot next. So our dummy node name is, what is our dummy node name? Let me check. Okay, okay, so the mistake was this. Okay, what was the mistake is, we were returning C. We have to return this in this function, right? No, I was returning here. So this was the fault. Let's return it here. Now let's try if it works. Even if there's an error, we'll rectify it if list dot is empty. Okay, this is not working. Let's see. Okay, okay, I found it. So instead of this, let's use something else. If list equal to null, let's try this. If this works, again we left this. Okay, now it should work. Yes, it is getting accepted now. Let's submit and test whether it is working for all test cases. Yes, it is. It got accepted. So it is right, very easy, right? First we have created a min priority queue and adding all the heads to this priority queue. Okay, and we have created a dummy node and brought our current node to dummy node. As we saw here, created a min priority queue, created dummy node, and brought our current node over to this dummy node, and what I have did, until our queue is empty, what we are doing, we are polling up until our queue is empty. We are polling out the element and adding it to the dumps next. Okay, I mean currents next. Okay, so that is what we did, and finally we have returned this dumps dot next, this one, this linked list. Okay, so this is the solution for this. Hope hope you have liked this. All the very best.